Hello, welcome back to Code with Roy. In our previous episode, we learned about RAG and we did a small POC on a AI agent which we created without RAG. But today we'll be understanding this concept of RAG again and we'll be creating an AI agent with RAG. So again, to understand the concept, the RAG has two different sections. One section which is this dashed section where we are ingesting a knowledge base to a vector store database, and which we have learned already in our RAG episode. So if you haven't gone through that, please go through that episode first so to understand the RAG concept completely, and then come back to this particular video where we'll be using this RAG. And then the second section is how we are using the RAG in below section, where someone is querying some question and then it's retrieving the data relevant knowledge base from the RAG and use pass it to the LLM and get the response back. Okay, so let's jump into the n8n. So what we are going to learn today is first this section. This section is nothing where we are means nothing but where we are ingesting the knowledge base to our Postgres vector data store. So how we have created this agent? This agent has nothing but this on form submission. On form submission will allow us to submit any document, be it a image, audio, text, anything. So this is that on form submission. And this is field name and file type we can give. We will be submitting a file here, and then this will be passed to Postgres vector store. So this component has two different sections. One is embedding. Any vector store need an embedding. Without that embedding, we cannot create the vectors. So whatever file will be passing here in this on form submission section, that will come to this embedding, and this embedding will create that embed, means create that vectors. We'll see how it is creating. And then we need this default data loader. Without this default data loader, it cannot convert the chunks. So we need a default data loader, and then we need to add a recursive character text splitter. So this splitter will basically create a thousand characters in a chunk, means it will create a chunk with 1,000 characters at a time, and then it will pass it to this default data loader, and then it will come to this embedding model, Ollama embedding model, which I'm running in my local. So if you see, this is running in my local, this Ollama embedding model. This will convert that chunk to a vector and store inside this Postgres PG vector store. So if you see this, this is a Postgres database. It's running in my local host. This is the database name, this is the username, the password is there, and it is running in my means Postgres runs in 543 default port, so it's running in 543 default port. And yeah, and then this is the table name. So when we configure this Postgres table name, you need to just create the configure connections. First you need to install that Postgres database in your local machine, and then you create the connection and then give the table name where you want to store the knowledge base. So this is my table name where I am going to store the knowledge base. So if you want to see the Postgres database, so I have installed pgadmin. So pgadmin will help to see, means it gives that user interface, GUI, basically to see the tables in GUI. Like, so this is that n8n knowledge base table. Now if you see, there is no data. We'll come back to this table. We have another table. This is actually storing the memories means the context for our AI agent. We'll be coming back to this table later on, but for now this is where we are planning to store our knowledge base, means vector, as a vector store. So now it doesn't have any data. So I hope you understood this setup where we are going to ingest the data. So now let's see how we can ingest the data. So I'll run this test workflow, and I will it asks me to insert the document or file. So I'll give this file. So this file is I have generated this file as a sample knowledge base for a restaurant, where it has multiple menu items in it, and with it price and then category, along with it some descriptions and ingredients, what are that menu ingredients are actually. So I have uploaded it, I'm submitting it, and I'll see what's happening. So you see this agent is running and it's loaded the data successfully. So let's see the data now. Coming back to the table, uh, let's run this query now, and you see it has inserted the data. So the amount of these chunks, right, we gave 1,000 characters at a chunk. So based on that, it's created 3 chunks and added 3 indexing, this UUID for each chunk and the metadata of the chunks, and then it gives this vector store. So this is the vector, this is the basically vector representation of this data. This data is this is the vector representation of the text, and which we have learned in our RAG section in detail. So again, if you haven't gone through that episode, please go and check that chapter where we learned about RAG. But overall, now we have created the vector store. So our knowledge base is now ready. Now we have to use this knowledge base. So let's go back to that n8n. This model is done. This model will work at the behind, means whenever we have to load the knowledge base, load any knowledge base, we can load more and more knowledge base using this AI agent. This will keep adding the data into this vector store. So this is done. Now we'll be going to the main AI agent, the chat model. So this is the AI chat model or chatbot. Say the restaurant has a chatbot, and end user can chat with that chatbot and get those details about that restaurant based on that knowledge base. So now this is the same Postgres vector knowledge database, if you see. So this has data now. So what will happen? First, this chat. So we have this chat component. This chat component is nothing but it will pass whatever the end user is chatting. It will pass. This is the initial message which we are planning to show. So this is that chat. It will come to that AI agent. We already learned in our previous video that how AI agent is generated. So AI agent has 3 main section. One is the model, which is the brain. So here I have the local chat model, Ollama chat model, which is running in my local. Second, it has the memory. This memory is basically holding the context of the chat, means whatever the past context of the chat, it will hold it. So it will keep stored in this context in the chat memory. So we are using here Postgres chat memory, and then you can add multiple tools. So I have, if you see here, I have used multiple tools, like I have used a calculator. So if we have to calculate some prices and all, say if I ask that, okay, what will be the price of 3 pastas, right, or 3 pizzas. So this calculator tool, this is a tool, this tool will be used to calculate that. Then we have this vector, this is that vector data store. And again, for any vector data store, we need a embedding model. So we have this embedding model, same embedding, Ollama embedding model. And then additionally, we have used another SARP API. So this SARP API is basically will do Google search. So say someone asks a question which is not in our knowledge base, then what it will do, it will instead of saying that okay, we do not have any knowledge about your question, it will search that question in SERP API, means in Google search. It will do a Google search and it will get some relevant answers, and then it will pass to this Ollama chat model and generate the overall response based on this SERP response. So this is the overall thing. Let's go and see how we have configured them. So this is the JSON chat input. Chat input is coming here as a prompt, and I have given him some instructions. You are a helpful assistant, rules response with a friendly manner. That's it, just for testing. And then the Ollama chat model. Let's see what we have in Ollama chat model. So Ollama chat model is my local configuration. So I have to pass that API key and then the base URL. This is my local base URL. And then I have to properly mention which model is running in my local, that model. If I change this model to someone else, something else, it won't work. So you have to give the exact model which is running in your local. So for my local, it's running 3.23 billion parameter model. So I've given that model name. So this is how I configured the brain of that AI agent. Then this Postgres chat memory. This is basically again my local. So I said I will be discussing this one. So this is the time. Now let's discuss this one. This is that table where we are holding the context as a chat memory. So if you see, there is nothing now because we never started any chat. So when we'll be start chatting, this will be filled with data. So uh, this is that chat memory basically. So this is my local Postgres database where it will be storing that chat information, and where it will store in this table n8n underscore chat underscore histories. And we are saying like 5 contexts it will store. So this is that chat memory. Then calculator is nothing but it's a tool. Basically it's useful if we have to calculate some mathematical operations we have to do, then you can add a tool as calculator. So I have added a tool. Means if I have to calculate, say someone asks what will be the cost of 3 pizzas, so this calculator will help to resolve that question. Means first it will get the price of one pizza from the knowledge base, and then it will calculate, and then it will pass it to Ollama chat model, then generate the overall response and pass it back. Okay, this is what we have learned. This is where we ingested the knowledge base now, and it has an embedding model. Again, this embedding model is nothing but our Ollama embedding model. This is running in my local, and the model name is nomic embedded text latest. So this is the model I am using as for embedding, and same model we used when we inserted the knowledge base. There also we use the same model to create that vectors. And then SERP API, as I discussed, right? So this SERP API, you have to create a key API key for SERP API first, and then you have to add that SERP API as a connection, and then that's it, right? Then it will connect to the SERP API. So now test this overall thing, how it works, or means how much it works. Let's see. So okay, let's first run this chat model. Hello. So I'll say hello. Let's see. So it's running AI chat model run. You see the memory got hit. So it stored that input to the memory. Now it is getting a response, and it will again store that response also in the memory and return it back to the chat model. So it is seeing actually what to answer. And this is the logs, what is happening at the behind. So right side, if you see AI agent and then Postgres chat memory, it is storing. It's taking some time because it's running in my local. If I could connect to OpenAI cloud LLM, then it could be much faster. But since I don't want to use any, I don't want to pay any money, and this is just educational purpose, so I am using my local LLM. It will take some time, but it will respond back. But it is not as accurate as if you plan to run it in cloud. So if you see it's done now, again you see the number 2 means earlier it's stored the request, now it's stored the response, and then this is the response I got. Hello, and it says, since I don't have any specific question or prompt, I'll create a sample function called demonstrator format. Okay, that's okay. Now let's ask something meaningful. Uh, so what if I ask, tell me about your menu item Caesar salad? If I ask, let's see if it's pass any answer from the knowledge base. Share me details about menu item Caesar salad, right? Let's see what happens. Again, this is running. Ideally, it should be hitting this tool section, this knowledge base. So that's what we are testing actually, that how and when it will hit it. Yeah, you see, it's hit the knowledge base, it got the response back. This is amazing. So it's got the knowledge response from the knowledge base. So while it hit this thing, it basically transformed this whole text to vector using this embedding, and then it got the answer from the knowledge base, and now it has passed it back to the chat model, local Ollama, and then it will form a response and send it back to uh, the chat model, means as a response. The only thing is this local LLM is not that efficient. That's why you won't see a very professional answer or professional response back to the chat. But if you connect to uh, cloud LLM like OpenAI chat models, then you will be seeing response much faster and much accurate. So we have to wait here because this is, as I said, this is running in my local machine and it's not that powerful. My machine is also not that powerful, neither this LLM. So it's taking time, but the idea is same, right? You just can replace this local Ollama chat model to OpenAI chat model, cloud based. Probably, if you really want to see that, I can do that. I have one account. So maybe in the next video, we can replace this one with OpenAI chat model, cloud-based, and can see the performance, how the performance is getting changed. For now, we'll be waiting for the response. It's taking time, but we can see what's happening behind the scene. So Postgres vector knowledge base has been hit. So this is what uh, came as an output. Our question was Caesar salad. Okay. Still working. It's taking a lot of time. But the thing is, overall idea is working, or overall concept is working. I'll definitely do another video um, just to replace this chat model with a cloud-based LLM and see the difference. But for now, we have to wait a little bit and see when the result is back. Now we have the result back. So you see the result is Caesar salad. Description: a fresh salad with romaine lettuce, blah blah blah, all these items. And then ingredients, it says, see these ingredients, it's give like in this order. We never had this one, so this is the magic done by this local uh, LLM model, means Ollama. And then it gave the price 8.99, category salad. Okay, so if you see the knowledge base now, Caesar salad is 8.99 salad. So this is how we successfully ingested our knowledge base, and based on our knowledge base it gave all the details whatever we fed to this AI model. So it didn't give any generic answer. So this is the purpose of RAG, and we have successfully demonstrated in this video how RAG is used. So this is it for today. uh, you can keep trying with multiple questions and see multiple answers how it gets generated. This is very useful, and without this, like it will be very difficult to understand how it works. But once you go to the in previous video where we discussed about RAG and then come back to this video and implement it, all your concepts will be absolutely clear. So if you like this video, please like and subscribe my channel and share this video with your friends. Have a nice day. Thanks.